Bismillahirrahmanirrahim. Today I will solve question number 4.17 from the book Design and Analysis of Experiments 9 edition, and in another edition it is question number 4.12. It is for your kind information that although it's a part of chapter number 4 in which there is RCBD, latent scale design, Greco-latent scale design. However, this question is based on one-way ANOVA concept because there is no blocking. There are only 3 treatment groups which we have to compare. The treatment groups are MP only, MP plus HD MTX, second treatment group, MP plus LD MTX, the third group. Each of the group has done observation. So first of all, the beauty of this question is that we have to check the normality, then comments on the normality assumption will not be satisfied, then we will do a transformation based on logarithm. That again we will check the normality assumption by using the residual analysis. So that's the beauty of this question. First of all, we will input the data in the Minitab software. So there will be 2 columns. Column number 1 will contain the treatment. So I have entered 10 times MP only, again 10 times MP plus HD MTX, and for the last 10 times MP plus LD MTX, and in front of each I have entered the observations. So first of all, the part number 1. Is there any difference? Is there any evidence to support the claim that treatment mean differ? So it's basically one-way ANOVA. So nothing else to do. Click on stat, then click on ANOVA, then one-way ANOVA. Here you will have to select the response variable. So in the response variable, we have the observations. And while in the factor there is a treatment, you will have to click on the graphs. In the graph, select 4-in-1 for the residual analysis and then click OK. So first of all, we will go towards the residual analysis. Click here to view only output. Come down and click on the graphs. So here are the graphs. It is quite obvious from the graph that the data has a problem of skewness, and you can see from this graph number 1 and the graph number 3 the histogram and the normal probability plot. So in order to tackle this problem, we will do some kind of transformation. However, first of all, we go towards the ANOVA result. So there is no difference found. However, we will not accept these results because our ANOVA assumption haven't met so far. Then what we will have to do? Part B, check the normality assumption. Can we assume these sample are from normal population? The answer is no, because there is a skewness in the data. So data is not normally distributed, or there is a violation of the normality assumption. You can also check the normality specific only for this data by the graph of the probability plot. Click on probability plot, then after single select the observations, click OK, and you will get a graph, and along with the graph you got the statistic value of the P. It is less than 0.005. So it means that data is violating the normality assumption. The Anderson-Darling test has been performed to check the normality of the data. Click OK, and then after that we go towards the next part. Take the logarithm of the raw data. Is there any evidence to support the claim that treatment mean differ for the transformed data? So first of all, we will have to take the logarithm. So click on calc, then calculator. Here first of all, select the function. So there are a lot of functions available, but you will have to select logarithmic. After that, select log base 10. Here instead of the number, click on observation twice so that the observation will come there. Then select the column in which you need the data to be stored. So I say log data. Then click OK. You will get logarithmic data. After getting this, again perform one-way ANOVA in order to analyze is there any evidence to support the claim that treatment mean differ for the transformed data. So you will have to go there and perform again stat ANOVA, one-way ANOVA. In the one-way ANOVA, instead of observation this time, select the log data, and again check that you have click on 4-in-1. This time also click on results and select the expanded tables, then click OK and OK. So by looking at the p-value, what it depicts, the p-value is greater than 0.05. So there is no statistically significant difference among these 3 treatments. Now the last part, analyze the residual from the transform data and comment on the model adequacy. So come down on the result sheet here and have a look at this residual analysis. So what you will see that as compared to the earlier data distribution, now it's quite good and our normality assumption is now satisfied. There are further two assumptions that are associated with the ANOVA. One of them is homogeneity of the variances, or you can say equality of the variances. So these are the residuals. Now above this central dashed line 0, the residuals are positive, and below this line the residuals are negative. Here you can see that the number of residuals above this central dashed line are somehow equal to the number of residuals below this line. So it means that variation in the data is constant. Okay. And we can see the assumption of the homogeneity of variances has been satisfied. Now the last graph. In this graph, you can see that there are no cyclic patterns, no trends, no 5 points are continuously going up or continuously going down. So it means that there is no collinearity issue in the data, and there is no multicollinearity has been satisfied. Although there is no statistically significant difference between the treatment, however, if you want to decide that which one is the better, so you can say that MP plus HD MTX is maximizing over value. If the objective is to minimize, then both MP only and MP plus LD MTX are equal. If we go slightly up, and here we can see what's the R square. So only 9.77% variation in the response has been explained by the 3 treatments we have taken in our question. So in this problem, we transformed the data, we have checked the normality assumption, we performed the residual analysis, then we performed the one-way ANOVA twice. Still, if there's any question regarding this analysis, please feel free to contact me on my WhatsApp number given on my email address. I just want to add one thing, that if you want to perform the regression analysis, then click on Stat, Regression, Fit Regression Analysis. Here select your response variable of the log data, because this data is following or satisfying the assumption. Then instead of the continuous predictor, click on the categorical predictor, and here select a treatment, because my treatments are the 3 categories. Then click OK, and you will get the regression analysis equation. You will also get the same thing, that you can see here the treatment MP only, it has a coefficient of 0. It means that it doesn't have any effect on the response variable. The treatment MP plus HD MTX has a positive effect on the response variable, while the treatment MP plus LD MTX has a very minute negative effect on the response variable. Hopefully now your concepts have been cleared. Still, I am available anytime. Have a good day. Bye.